Okay, now we will discuss optimization problem of explicit representation. Optimization problem of explicit representations. So why explicit structures struggle in deep learning? So the optimization problem. See, basically we cannot do the deep learning with explicit representation. Once again, I'll tell you what it means. See, the idea is that we represented a scene in 3D, like a 3D representation we did using explicit representation. So 3D representation we can do either using point clouds or voxel grids or polygon meshes. Now the problem is that they are discrete in nature, and because of that, gradient descent we cannot do, because optimization using AI, especially the deep learning, that we cannot do because that involves gradient descent, and gradient descent it requires continuous parameters, because if it is continuous then only it will be differentiable, and unfortunately explicit representation it is discontinuous, it is discrete, and hence gradient descent we cannot apply here, and that is the optimization problem of explicit representation. So if you represent a 3D scene using explicit representation, you cannot uh, use neural networks to optimize it. And one more disadvantage, like the optimization problem, is meshes and voxels. They have discrete topology, hard to optimize shape directly. So the key takeaway for us is that explicit geometry is great for rendering. So for real time rendering, it is very good. Like you can represent, but it is difficult to learn automatically. And what is the meaning of learning? See, the idea is that if I want that, okay, any change, it should automatically adapt without we running the algorithm. That is not possible with explicit geometry, explicit representation. Because in explicit representation, any change in the topology, we have to rerun the mesh algorithm. It cannot adapt in real time. It cannot adapt in real time. And that is the very big drawback, because now we are living in a world of AI, wherein software systems they're adapting based on the uncertainties of the real world. It is adapting, but explicit representations they cannot adapt. A small change in the shape, we have to rerun the mesh algorithm to fill the space, and that too in the same way. So that's the problem.